GenAI, spatial computing, IoT, and AWS. We're going to use a Magic Leap 2 along with the Boston Dynamics Spot to bring together AWS with the physical world. I'm going to build out a pipeline using SageMaker to understand the Spot robot and all of its telemetry. So here we are in the console. What we're going to do is create the Spot robot and other assets that we're going to look to visualize their data in the AWS console using a few different services, one called AWS Sitewise, another called AWS IoT TwinMaker, and we're also going to use a Grafana visualization engine eventually. But right now what we're going to do is just demonstrate simply how you can bring in assets, you can measure against those assets, and this is a very small amount of the assets that you can measure against in the Boston Dynamics Spot. This is just for demonstration. But what I did is I just grabbed a few of the things that might be important, like the battery, direction, speed, and temperature of the Spot robot. And then you can add all of your assets here, or bring them in from other sources as well. And then from there, I'm going to, you can see here, some of the metrics have already been being passed. This is a dummy value because the Spot is off. But if I were to turn the Spot on, it would actually start to send real values. And I'm just sending these values from the console, from the shell, a program that's normally be running on the Spot, but in our case, we're just going to run it in the shell. And it sends values that are consistent with battery, and this would be a low battery. And what we want to do with these kinds of things is we want to use GenAI not only on the Spot to work out, ensure that it's performing as it should be, but everything around it, all the IoT sensors, data that it's collecting. We want to check whether things like valves, indicators are working as they should be. Steam gauges is what we used to call them back in the day, and other things are working as they should be. So as the Spot walks around, we're going to send all of its data that it gathers, visual data, data that it's gathering, like temperature sensing for externals, and other sensors that the Spot can have on its payload on its back, and send those to AWS. And once they're in AWS, we can do things like we can measure directly against known good conditions, which is probably the simplest way to do these things. And then we can also transform that data into other things, like, for instance, temperature I like in Fahrenheit and not Celsius. Hard for me to do my conversions in my brain. The other thing we can do is, look at certain metrics at certain timestamps and say, like, what is the max temperature this thing's been operating at, or what's the battery draw, let's say, how much amperage is being drawn against the same battery. And then obviously alarms makes the most sense. But here's how we connect GenAI to this conversation. This is happening over the course of one Spot robot or one IoT device at a singular point in time and space. We'd like to maybe look at trends, and you can use IoT TwinMaker to look at trends. But you can also use GenAI for the same purpose and say, okay, over the course of a year, and all of my various incarnations of my various robots and IoT sensors, what sensors are degrading? What sensors need maintenance because there's a manufacturer spec against it that says we need to do some kind of operational performance checks / just routine maintenance, regular pre-planned maintenance against this asset. And then you can have GenAI manage all of that for you. Yes, it would take a while for you to build up that kind of resource, but it's something that's absolutely doable. Not only here, we are going to use GenAI as well to do a lot of the video processing and to be able to ask questions of the Spot and say things like, Spot, what are you looking at now? Spot, go to this particular area that you not, pre-categorized before. Spot does have its own software and it does auto walk missions and things like that. But visually, you can give it directions or natural language based things to do, and it can go off and do those things. Or enough of that. Um, so once you have all this stuff, the next thing you want to do is essentially build up a digital twin. And here I have a digital twin of the spot. What you see here is the 3D model of a basic spot. This is not a accurate model, but it was good enough for what I'm trying to do today. And imagine many different assets like this. And we're using this visualization, but really the thing that we're mostly interested in is the telemetry that's coming from the spot. So we're going to assign some rules. We're going to annotate the 3D model, and we'll show this in Grafana as well as you will see in a later demo when we show the tabletop visualization. That'll be this with annotations on top of it. And we're in the process of finishing that part up. But if we're talking about strictly GenAI, and that's the focus of what we're doing here, what we're trying to accomplish is get these IoT devices, robots, all of its parts, rooms that it's in, all of these things into a format and data so that we can send this to our various tools. We have a tool called SageMaker, which manages the creation of models, the fine-tuning of models, etc. And it also allows you to pick, certain types of, let's just go there so you can just see for a second. Certain types of you would consider like a workflow for, figuring out what it is you're trying to do. So let's say I knew I wanted to do something with computer vision, or I knew I wanted to do something in natural language, especially using a large language model. I can use SageMaker to quickly build up that environment. So I'm just going to show how easy it is to deploy. Here I'm looking at Minstrel 7B Instruct, and I can click on deploy and it'll actually go off and deploy this asset. We're not going to do that. And then quickly when you're done, you can also run in Notebook. If this model is trainable, you can train this model, and then you can see the, a description of the kind of inputs and outputs that you get from this model. So this is just one of many. So if you go here and you look at the launcher, there are tons of different jumpstart models to get started with. We also have a tool called Bedrock, which is, we're not going to talk about here, but the idea is still solid that, we have our own kind of tool that does some of these things. And Pro offers our own models like Amazon Titan, etc. What would you use all this for? Well, great. We talked a bit about that, things like prediction. Another thing about cases that you haven't yet built. You haven't yet built out, but you want the robot to do something. And in our case, what we showed at the beginning is more of a person walking around, looking, inspecting things, wants the spot to actually inspect those same things. So the first thing the spot is doing is following. There's a mode on the spot that's been built by Boston Dynamics called Follow Me, and it allows the spot to follow. And it does things like object avoidance, for obviously safety reasons. But then once you're at the thing that you're looking at, you want to be able to tell the spot to do something in natural language, and then have the spot, correspond and do what you want it to do. Many ways to accomplish that, and we have a service called AWS Transcribe, and what that does is it takes a WAV file from wherever your source. In our case, it's the Magic Leap 2, and then from that source, translate that or transcribe that into natural language. And then also, if you wanted to, you can also run a translation pipeline if you wanted to only support certain languages, or if the model you're using only supports certain languages. Next step from there is simply to call one of these large language models that supports you sending some kind of agent or some kind of function to the model. In our particular case, what we've done is we said, okay, the Boston Dynamics spot can do certain things, has certain attributes. And as the user requests certain things, like say, go look at that electrical box. What we're doing is we're saying, okay, find an electrical box. And then if we use the multimodal large language model, which we don't have here yet, but I'm sure they're coming soon, we can do things like, say, just pass the natural language to the Spot's visualized data, so its cameras, and then from there get back instructions. That's a little bit more complicated than we're doing right now. Right now, we have a model running that's taking in the natural language request, and we also have another model running that's looking at the visualization and doing an object detection pipeline. And then finally, we're telling the Spot to go toward that environment, turn, look up, or look down, whatever it might be, to center the content, the center of that in the object that you're trying to look at in the field of view. So it's a bit of complicated math to come up with that stuff, but it's very reasonable. Okay, that's enough of this, and let's get back to the rest of the demo. Well, there's a little bit behind the scenes here at what was built, what we actually built at the very beginning, and then partnership with Magic Leap, which did the UI that you're seeing in front of you, and a developer on our side named Roger Kinney, who really built out the user experience that you see. But what we have is a Python WebSocket that is connected to AWS WebSockets. And what it's doing is it's sending all of the various pieces of data. As you see here, we just logged into the Spot. And as we log in, you'll see that the Spot will pick itself up and correct itself. There you go. And so it sensed that it was not in the correct state and sent a command over to the Spot to correct itself. And that's something that you can do in our tooling. If you want to use lambdas, step functions, all kinds of different ways to do that using a service that we have called AWS IoT Greengrass that can manage this kind of environment for you. So we're sending the data from the Spot, just like we talked about before, and doing some random actions with the Spot, like making it kind of do push-ups here, where it's standing up and sitting down over and over and over again. And as it stands up and sits down, it's sending all that telemetry data to AWS for management. Moving around, changing its view just a little bit so that we can send that telemetry data, that quaternion of it moving around, etc. Speeds, all of those things, anything that it's doing can be managed by both AWS and models internally. So you can run models that can determine whether the speed that it's at it's appropriate for where it's going to be. Say it's about to go through a crowded room, and you want to just slow it down, even though the Boston Dynamics Spot does have obstacle avoidance and object detection, etc., and can definitely go through a crowded room quickly. What you might want to do is just preemptively settle the Spot down a little bit, slow it down maybe, and that you can use a vision model to do those kinds of things. Another use case for GenAI. As you can see here, shutting the Spot down because the battery has gone low, and that was all done because the model intuitively knew that the battery needed to be changed. So here we are in more of a demo of the functionality of the user experience as it's kind of blown up here. This is not really involving a lot of GenAI, but the concept is still sound. You have a user wearing a Magic Leap, and a Magic Leap has onboard compute, and as you can see, it has a handheld controller, and this particular Spot doesn't have the nice 4K camera on the back, but the views that you're seeing are views that the Spot sees and how it views the world, orientates around the world. So it uses these various cameras to do obstacle avoidance. And then there's this kind of sensor fusion here, where you want to bring some of the data from the Spot, from the Magic Leap, have that all combined in IoT TwinMaker, and then brought back to a tabletop representation of where the user is, where the Spot is, and being able to move the spot even around that tabletop or by hand using various controls that we have. We have a kind of IMU sensor inside of the controller that allows the spot to move around, and we also have this kind of grab and kind of fish line controller is what they use in spatial computing to allow the spot to move. This all culminates in directly inspecting something. So here we have a person in spots in follow me mode, but when the user decides they want the spot to inspect, she selected inspect, and now the spot is going to figure out the best way to orient itself in front of the item that it's going to inspect, and then finally stop and inspect. And there you go. I was assisted by Roger Kinney in this demo locally, Heidi Buck, also from AWS, as well. Some of the core concepts came from Jeremy Wallace, and outside of AWS, we also had a few other people from Magic Leap that assisted us, Christian and Adrian Babalinsky, as well as others. Thank you.